it's Mrs. Scarpel again, and we're going to finish our conversation on solving absolute value inequalities. In our last video, we looked at absolute value inequalities where the absolute value was less than. In this one, we're going to look at the absolute value is greater than. So in this example, I have the absolute value of x is greater than 2. So we're looking at which values have a distance that is greater than 2. So if I take and think about my number line, we know that 2 and negative 2 have a distance of 2, but we're not going to include those numbers. I'm going to go ahead and place circles on those numbers because I know I'm not going to include them, but I'll get really close to those numbers. Now, let's just plot some numbers, put some points on some numbers that will work. Does 1 have a distance that's more than 2? No, it doesn't. Does negative 1 have a distance that's more than 2? No, it doesn't. How about 4? Yes, it does have a distance more than 2. How about negative 5? Yes, it does. How about 0? No, it doesn't. How about negative 3.5? Yes, it does. How about 5.5? Yes, it does. So hopefully what you're noticing is the values that work are going to be greater than 2 or less than negative 2. We have an or situation here. We have what looks like oars on a boat. We have an or situation here. So when we're working with absolute values that are greater than a value, we have an or compound inequality. So when I write the compound inequality for this graph, I have x is less than negative 2 or x is greater than 2. So when we solve these, we're not going to write that sandwich that I mentioned with the ands. We're going to write two separate individual inequalities separated by the word or. One will be less than the negative value, and one will be greater than the positive value. And that's what we're seeing with this expression up here. So we've got the ax plus b is going to be greater than positive c, or ax minus b is going to be less than that negative c, as long as c is greater than 0. So when we solve this, I need to write that x plus 1 is greater than or equal to 3, or x plus 1, meaning the distance that x plus 1 represents, will be less than negative 3. And I need to solve each inequality separately. So I'm going to subtract 1, and I will find that x is greater than or equal to 2, or when I subtract 1, x will be less than or equal to negative 4. And then we can graph that. Negative 4 is on the left because it's a smaller number. 2 is on the right. Because of the equal to, we are including both of those. So we need to have a solid circle. And we will have arrows to the left of negative 4 because we're less than negative 4. And to the right of 2 because we're greater than 2. Now if we look at b, we have a mistake here. Let me fix this. Let's make it 12 plus x. There we go. That makes more sense. If I were to solve this, absolute value of 12 plus x is greater than negative 5. I'm talking about a distance is going to be greater than negative 5. So distance is always positive. Isn't a positive number always more than a negative number? I hope your response to that is yes, a positive number is always more than a negative number. So our response to this, or our solution to this, is all real numbers. It doesn't matter what I put in for x. Whatever I put in for x, this will always turn out to be a positive value, which will always be greater than -5. Now, you might be asking, so what's the graph look like? Well, the graph is just every number on my number line. It is the entire number line. Every number on that number line is a solution to this. And it's because positive is always greater than negative. So if you have an absolute value is greater than a negative, it's always going to be all real numbers. Excuse me. So here's your opportunity to do some practice. Now, notice that some of these are absolute values that are not isolated, so make sure you isolate your variable before, or your absolute value, before you determine anything. Just a hint there. But here's your opportunity to solve some absolute value inequalities. Now that you've had a chance, let's see how you did. So we have absolute value of x plus 3 is greater than 8. So we're going to have x plus 3 is going to be greater than 8, or x plus 3 will be less than -8. And we need to solve each of those. We need to subtract 3, so x will be greater than 5, or subtract 3 as well on the other inequality. X will be less than -11. And then when we graph that, -11 is on the left, +5 is on the right. We do not have an equal to, so they both have open circles. We're more than 5, so that arrow goes to the right. We are less than -11, that arrow goes to the left. For the inequality on B, before you do anything, you need to add 3 to isolate the absolute value. Do not make any decisions about the problem until you have isolated the absolute value. So it turns out we have the absolute value of n plus 2 is greater than or equal to -3. So we know that absolute value is a positive value because it is distance, and we're saying it is greater than -3. Well, positive is always greater than negative, so this is all real numbers. And my graph is the entire number line. And for C, again, you want to isolate the absolute value before you do anything. So you want to add 7 to both sides. So we have 3 times the absolute value of d plus 1 is greater than 6. And then we need to divide both sides by 3 so that we have the absolute value of d plus 1 is greater than 2. Now we can look at this. I have an absolute value greater than 2. That means I'm looking for numbers that have a distance of more than 2, which we've already talked about is possible. So D plus 1 has to be greater than 2, or D plus 1 has to be less than negative 2. Solve each inequality. And we have D is greater than 1, or D is less than negative 3. Negative 3 is the smaller number. It is on the left. 1 is the larger value. It is on the right. We do not have an equal to, so we have open circles on this graph. Greater than 1 is an arrow to the right. Less than negative 3 is an arrow to the left. And that is how you solve absolute value inequalities when we have the absolute value greater than a number.